Okay, good morning. This is the third video na isesend ko sa inyo, na sinend ko sa inyo. So, the title of the topic is about complex voltage applied to pure inductance. So, if the applied voltage has complex form and is given by this kind of equation, E is equals to E1 maximum sine omega t plus E3 E3 M maximum sine 3 WT and E5 maximum sine 5 omega t. Ang tawag dito harmonics eh. So then the reactance offered to the fundamental voltage wave and the harmonics would be different. So for the fundamental wave, yung reactance 1 is equal to the angular frequency times the inductance. For the third harmonic, the reactance 3 is 3 times the angular frequency times the inductance. So the harmonic in the current wave are much smaller than the voltage wave. For example, the fifth harmonic of the current wave is only 1/5 of the harmonic in the voltage wave. So for the fifth harmonic, ang formula niya is 5 times the angular frequency times the inductance. Hence, the current would be given by the equation IE1 maximum over angular frequency L sine omega t minus 20 plus E3 maximum 3 over 3 omega L sine 3 WT minus 90 plus E5 maximum over 5 omega L sine 5 WT minus 90. E1 maximum sine omega t plus E3 maximum sine 3 omega t plus E5 maximum sine 5 omega t. The reactances offered in the fundamental voltage wave and the harmonics would be different. For the fundamental wave, we have X1 angular frequency times L. For the third harmonic, 3 angular frequency times L. And yung fifth harmonic, ito, no? Teka, nakahiwalay siya eh. Ito dapat na nasa taas. Ayusin ko lang. Ito dito. So, bababa ako ito. Yan ang magiging itsura niyan. E maximum sine omega t, ito yung formula niya, no? General formula niya, plus E3 sine, E3 maximum sine 3 omega t para sa voltage kasi ito. Plus E5 maximum sine 5 omega t. Ito current, ito voltage. So then the reactance offered to the fundamental voltage wave and the harmonics would be different. So example, a 50 Hertz voltage of 230 volts effective value is impressed on a capacitance of 26.5 microfarad. Letter A, write the time equation for the voltage and the resulting current. Let the zero axis of the voltage wave be T is equals to 0. Show the voltage and current on the time diagram. Show the voltage and current on the phasor diagram. So, ito yung mga given natin, no? We have 50 Hertz for the frequency, 230 volts for the RMS voltage, and the capacitance is 26.5 microfarad. Required equation for E and I, let T is equals to 0, E and I in the time diagram, E and I in the phasor diagram, at saka yung maximum energy na nai-store dito sa capacitance, no? Hindi nakasalagay dito. Show the voltage in the phasor diagram. Letter D, maximum energy stored in the capacitor. So, yung solution natin, yung unang-una, equation 1, we have E is equals to E maximum sine omega t. And yung current naman, since na capacitive ito, nagli-lead yung current ng 90 degrees, we have I maximum sine omega t plus 90. So, huwag nyo kakalimutan, pag resistive, in phase, wala siyang phase angle. Pag inductive, nahuhuli yung current ng 90 degrees sa voltage. Pero pag capacitance, nauuna yung current ng 90 degrees sa voltage. In-explain ko na yun doon sa previous video natin. So, E maximum is equals to square root of 2 multiplied by 230 volts. Ang makukuha mo dyan ay 325.269 volts. So, the angular frequency is 2 pi f. So, 2 pi multiplied by 50, since na 50 yung frequency, nakakuha tayo ng 314.159 radian. So, E is 325.269 sine 314.15 from 0.1590. Ito yung equation ng voltage, no, na tinatanong dito. The next, yung capacitive reactance is 1 over 2 pi Fc or 1 over 2 times pi times 50 times 26.5 times 10 to the negative 6. Ang capacitive reactance is 120.1169 ohms. I maximum is E maximum over XC or simply 325.269 volts over 120.1169 ohms. Therefore, I maximum is 2.7079 ampere. Therefore, makukuha mo yung current as 2.7079 sine 314.1590 plus 90 or 2.7079 cosine 314.1590. Yun ang equivalent dito, no, sa cosine. So, E and I in time diagram. So, this is capacitive. Nauuna yung current ng 90 degrees, no, sa voltage na in phase sa 0, 180 to 60. Ito yung diagram. So, phasor diagram yun. Time diagram pala ito, no? Time diagram yan. Ito yung phasor diagram. Angle lang nakalagay pag phasor diagram. So, itakal ko na rin ito. Kasi sayang naman yung video kung maikli lang. Para sa susunod na meeting natin, dire-diretso na tayo kasi medyo nahuhuli na tayo. So, circuit diagram, resistance and inductance in series, RL series to. So, this time combination ng resistance at inductance. ER is IR, EL is IXL, no? Current times resistance, current times the inductive reactance, where XL is 2 pi FL. Ito yung vector diagram pag ganyan, no? Combination ng resistance at inductance. Kung mapapansin mo, ito yung resistance, ito yung voltage ng resistance. ER ang tawag natin. So, nauuna ang ito yung current axis eh. Ito yung pinaka-current axis nyo. Tapos, nauuna ang voltage ng inductance sa current. Diba sa pure inductance natin, EL leads 90 degrees dun sa current. Kaya dito kinumbine mo, yung ER na pure resistive, zero resistance. As wala siyang phase angle. In phase siya. Ito, nauuna siya ng 90 degrees sa current. So pag kinuha mo ng resultant niyan, lalabas itong total voltage na E. So paano diniderive yan? Ito yung parang Pythagorean. Gagamitan mo ng Pythagorean yan. Ito yung E, ito yung ER, ito yung EL. So using Pythagorean, you have E squared is equals to ER squared plus EL squared. Or simply ER squared plus EL squared square root. No? Voltage formula yan. So ngayon, itong E, ang formula niyan is I times the impedance. Yung say kasi stands for impedance, no? Which is equal to ER squared is IR squared plus EL squared is I times XL squared. Then, i-distribute mo ito yung square, I squared R squared plus distribute mo din to I squared XL squared. Then, factor out mo itong I squared. So, factor out mo. Matitira dito sa parenthesis is R squared plus XL squared. Kunin mo yung square root ng I, magiging I na lang, no? Ang matitira sa square root itong dalawang ito. So, dito sa I say, pwede mo i-cancel yung I. Kaya yung impedance formula natin ay say equals to square root of R squared plus XL squared. Where say is the impedance in ohms, R resistance in ohms, XL inductive reactance in ohms. Ito yung mga formula na tatandaan nyo. XL is 2 pi FL. XL is also EL over I. Yung voltage drop dito. Ito yung EL eh. Yun ang formula. Ohms law lang din. And yung resistance, ER over I, no? Dito. So the impedance is E over I, no? Ito, yung bukabuuan nito na impedance, E over I. So ito yung impedance triangle natin. Ito yung R, ito yung inductive reactance, ito yung impedance. So power factor is cosine theta. Ano ba cosine theta nito? R over say. Ito. Yung power factor. An inductive power factor has always a leading power factor. Tandaan nyo, leading ang power factor ng inductive. So, malinaw, no? Dito sa circuit na pinapaliwanag ko, sabi niya, an inductive power factor has always a leading power factor. Paulit-ulit yung sinasabi yan. Yung theta, ito, phase angle in degrees. So, kung gusto mo makuha yung angle na to, kunin mo yung arc cosine nung R over say. Arc cosine ng R over say. So, theta, arc cosine ng R over say, or arc tangent ng XL over R, or arc sine ng XL over say. So, example, a circuit with 0.1 Henry inductance and 20 ohms resistance in series is connected across a 100 ohm volts, 25 cycle mains. Determine una yung impedance, B yung current, C yung voltage across the resistance, D yung voltage across the inductance, and E, angle by which the voltage leads the current. So, yung inductance natin is 0.1 Henry as given. Resistance is 20 ohms and the voltage is 100 volts. Frequency is 25 cycles per second. Required yung impedance, yung inductance, yung voltage drop ng resistance, voltage drop ng inductance, tsaka phase angle. So, solve na natin. So, illustration muna. Drawing natin yung circuit, no? Ito yung ER, ito yung EL, resistance, inductive reactance, no? Solvin muna natin yung inductive reactance. Inductive reactance has a formula of 2 pi FL. So 2 pi times 25. Yung frequency niya is 25 times the inductance which is 0.1 Henry. Nakakuha tayo ng 15.708 ohms. Yung formula ng impedance naman ay R square root of R squared plus XL squared. So square root of 20 ohms squared plus 15.70 ohms squared, makakakuha ka ng 25.4311 ohms. So the voltage is equal to I say, I is E over say 100 divided by 25.4311 ohm. Makukuha mong current is 3.9322 ampere. So the voltage drop, yung current na tinutukoy dito ay ito yung current na nagdadaan dito. Parang ohms law din, no? Yung voltage I say, solve for I, yung total voltage na E over the impedance. Ito. 100 volts divided by 25.4311 ohms, nakakuha tayo ng 3.9322 ampere. Ito. So ER is equals to IR. So 3.9322 ampere times 20 ohms, makukuha mo na 78.6433 volts. Yung voltage drop dito. Tapos yung EL equals to IXL. So ang current natin, alam natin na 3.9322 ampere times yung X sub L which is 15.708, nakuha natin is 61.767 volts. So ito ngayon yung impedance triangle natin. Let us solve for the phase angle. So there are many ways of solving the phase angle. In this case, cosine yung ginamit. Ang cosine ng triangle na ito ay R over say. So kunin mo yung R cosine ng R over say para makuha mo yung angle. So R cosine of 20 ohms over yung impedance 25.4311, makakakuha ka ng 38.41461 degrees. So yung phase angle is R cosine of ER over E. Taas natin, no, para makita. So R cosine, yung angle is R cosine of ER over E. Ito isang way ng pag-solve din, no? Kasi yung pinagbasihan natin dito yung impedance triangle para makuha mo to. Pareho lang. Kasi dito R over say, dito naman sa impedance triangle, sa voltage triangle, ito yung sample ng voltage triangle in our previous yung voltage triangle ito. O ER over E is cosine. So, pakita ko sa inyo to. ER over E, 78.6433. Ito. No? Divided by E. 100 volts ang source voltage natin. Nakakuha tayo ng 38.1466 degrees. Example 2. A 6 ohms resistor and an 8 ohm inductive reactance were connected in series across a 60 ohm cycle supply. Take 12 ampere. Determine the impedance of the circuit, voltage across resistor, voltage across resistance, circuit voltage, power, angle between current and voltage, power factor, inductance, at saka draw yung vector diagram. So ang given natin, 6 ohms yung resistance, inductive reactance is 8 ohms, frequency is 60 cycles per second, at saka yung current ay 12 ampere. Ang hinahanap yung impedance, yung voltage drop ng resistance, voltage drop ng inductance, yung total source na E, ito. Yung power, yung phase angle, yung power factor, yung inductance, yung vector diagram. Itong power, nandirito yan sa resistance. Ang tinatawag nga natin yan na true power. So ito yung solution natin. We have the impedance equal to 6 squared plus 8 squared. Nakakuha tayo ng 10 ohms, no? Square root of 6 squared plus 8 squared, square root yan, no? Then, taas natin. Letter B, yung voltage drop dito, kunin natin. Ang voltage drop is ER equals IR. Simpleng ohms law lang, no? 12 amperes yung current, 6 ohms yung resistance, nakakuha ka ng 72 volts. So sa makatuwid, 72 volts yung ER. Yung EL ay XL, 12 ampere times 8 ohms. So 12 ampere yung total current as given. Tapos yung XL is 8 ohms. Given. Nakakuha tayo na 96 volts. Then, we go now to letter D. E is equals to I say 12 ampere times 10 ohms, 128 volts yung source voltage natin. Letter E, yung power. Sabi ko kanina yung power, nandito sa lugar na yan, no? Across dito. Nandiyan ang power. Kaya tawag nga natin na power dissipated or true power. Kunin natin yung power. Power is I squared R. So 12 squared times 6 ohms, nakakakuha ka ng 864 watts. Where E true power in watts, Q reactive power, bar volt ampere reactive, and yung S yung apparent power, volt ampere. So F theta are cosine of ER over E. So theta cosine 72 volts over 120 volts, makakakuha ka ng angle na 53.1301 degrees. Power factor cosine theta ER over E, R over C equals to P over C. Power factor is 6 over 10, nakakuha tayo ng 0.6 leading. Power factor is cosine. No? Lahat ng cosine dun sa triangle na pwede mong gamitin, gawin mo. No? The voltage triangle, impedance triangle, or power triangle, meron din. Introduce ko yun later. So, XL is 2 pi FL. L is XL over 2 pi F. So, L, 8 ohms over 2 pi 6 ohms. Let us solve for L, which is 21.2 millihenry. Kasi given naman yung XL. Pwede mo ma-solve yung inductance. So, ito yung vector diagram niya. No? Ito yung ER, ito yung EL, ito yung resultant niya, which is the applied voltage, ito yung phase angle niya. So, reactive factor is given by the formula of sine theta. Kabaligtaran nito ng cosine theta, no? Where R reactive factor. So, bibigyan ko kayo ng assignment, no? Hanggang dito na lang muna tayo sa RL. Susunod kasi RC na. So, ito yung assignment nyo. Saglit lang, ha? Sisend ko lang sa GC natin. Okay, class. na-send ko na yung ano no, yung assignment nyo. And then ito yung susunod na topic natin, no? Resistance and capacitance in series. Tapos magdi-derive ako dito, no? Bale, ano, tapusin ko na, no? Tuloy ko na rin para dire-diretso tayo. So, resistance and capacitance in series, RC. So, wait lang ha. So, pag capacitive, resistance at capacitance ang combination, makikita mo yung vector diagram niya. Yung voltage ng resistance, of course, in phase pa rin, pero yung voltage ng capacitor ay nahuhuli sa current. Ito kasi yung parang axis ng current. Nasa axis ng current yung resistance voltage, pero out of phase ng 90 degrees yung capacitive voltage sa current. So ano-ano ba ang condition sa RC circuit? Yung current I is the same in both R and XC. The current I is used as the reference vector. Ito yung reference vector. The current I is leading with respect to the voltage. The voltage ER is in phase with the current. The voltage EC lags the current by 90 degrees, no? Wait lang edit ko lang ng konti ito. 90. Walang superscript kasi dito. 90 degrees. Okay. Then, derivation, consider the voltage triangle. Ito yung voltage triangle natin. Ganyan na magiging itsura niya kasi nauuna nga yung current sa voltage. So, E squared, ito, is equals to ER squared plus yung tinatawag natin na EC squared. But ER is equals to IR, EC is equals to IXC. So, E is equal to ER squared plus EC squared. Yung square root niya, yung general formula ng voltage triangle. Also, ang formula ng E ay I times the impedance, which is equal to the square root of, ang formula ng ER is, ER squared is I squared R squared plus ang formula ng EC squared ay I squared XC squared. So, ipapactor out mo itong current na to para ang matira na lang sa loob ay R squared tsaka XC squared. Tapos kunin mo yung square root. Eh, syempre, hindi mo naman makukuha yung square root nito, no? Dahil mga literal, ano yan, literal values. So, kunin mo yung square root ng I squared, I na lang siya, mawawala yung square root niya. Pwede mo na ngayon i-cancel ito. Kaya matitira, impedance is equals to the square root of R squared plus XC squared in ohms. Ang impedance ay may formula rin na E over I. Parang ohms law din, no? The voltage divided by the current. Ang formula ng capacitive reactance ay 1 over 2 pi times the frequency times the capacitance. And in short, pwede mo rin siyang isulat na 1 over the angular frequency kasi ang formula ng angular frequency ay 2 pi f. Ang unit niyan ay ohms din. So, X sub C, capacitive reactance yan in ohms. Yung E sub R, voltage drop across R, B. Then yung E sub C, voltage drop across C. So ito naman yung tinatawag natin na impedance triangle. Ito yung resistance, capacitive reactance, at saka yung impedance. O baka nakalimutan nyo, kaya nakaganyan yan kasi mas nauuna yung current sa voltage and sumusunod din yung impedance triangle sa voltage triangle. So yung tangent theta, opposite over adjacent is negative XC. Bakit negative? Pababa eh. Negative XC over R. Power factor is cosine theta, R over C, which is equal to ER over E sa voltage triangle. R over C, ER over E sa voltage triangle. Reactive factor is sine theta. Paano ba ang sine theta? Opposite over hypotenuse, no? XC over C, and reactive factor, yung EC, capacitive voltage, ito. Tignan natin yung voltage. EC over, EC over E. Ito, EC over E. Negative dapat, no? Lagyan natin ng negative sign para maging consistent tayo. No? Teka, alin ko muna yung pansulat ko. Wait lang ha. Kasi kinukonfigure pa yung pansulat eh para magamit, no? Okay, so saglit lang. Okay, na-configure ko na. Lalagyan natin ng negative dito. Kaya negative kasi pababa. Positive pag pataas. Pag sa right, positive din. Pag sa left, negative. Okay? So meron tayong sample. No? So ito yung note natin. Ha? A capacitive circuit has always a leading power factor. Inductive, lagging. So sabi, a tungsten filament bulb rated 500 watt, 100 volt is to be connected in series with capacitance across 220 volts. 50 hertz supply. Calculate the value of the capacitor such that the voltage and power consumed by the bulb are according to the rating of the bulb. B, the power factor of the current drawn from the supply, and draw the phasor diagram of the circuit. So ang rated power natin ay 500 watts ang rated voltage natin ay 100 volt, no? Which is ER also, no? Pag sinabi mong E-rated, yung input niya ay 200 volts, ang frequency ay 50 hertz. So, ang hinahanap yung capacitance, power factor, tsaka phasor diagram. So, ito yung illustration natin, no? 220 volt source siya. So, R is ER squared over the power rated. No, yung ER yung power. Nandito kasi sa bulb na to, resistive kasi ang bulb, no? Yung ilaw. Nandito sa voltage drop niya, yung power. Para ma-solve mo yung power, no? So, kunin muna natin yung resistance ng ilaw. Para makuha mo yung resistance ng ilaw, ER squared yan over power rated. No, yung rated power. So, from power formula yan na power is equals to B squared over R, no? So, resistance is 100 volts squared divided by the 500 watt na power rated, nakakuha tayo ng 20 ohms. So, 20 ohms pala itong bulb na to, no? Then, yung current na dumadaloy, no? Dito. Isang current lang naman yan dahil naka-series yan. So, yung power rated divided by the voltage rated, we know that power is voltage times current, no? E-rated times current is power rated. So, 500 watts divided by 100 volts, makakakuha ka ng rated current na 5 amperes, yung current na umiikot dito. So, E squared is equals to ER squared minus EC squared. Ito yung nakuha sa Pythagorean or sa voltage triangle. No, yung voltage triangle, ganyan ang formula niyan. So, we are going to solve for the voltage drop na EC. So, EC squared is equals to E squared minus ER squared. Negative EC squared is equals to 220 volts squared minus 100 volts squared. Negative EC squared is 3,000, 38,400 volts squared. No, naka-square yan. So, kunin natin yung E sub C. Kunin mo yung square root ngayon yan. Kasi getting the square root of both sides, magiging E negative EC na lang to, tapos square root mo itong buong ito. Diba? Isa yan sa mga laws of algebra. So, E sub C is negative 190 kasi divide mo. We are assuming that there is a negative 1 here. So, divide mo sa negative 1 to, E sub C na lang yan, or the voltage drop of the capacitance, which is equal to 195.9592 volts. Since E sub C is equals to negative IXC, at saka yung X sub C is negative E sub C over I, X sub C will be given as negative 195.9592 over 5 ampere. X sub C is negative 39.1918 ohms. So the capacitive reactance is 1 over 2 pi Fc. The capacitor is given by 1 over 2 pi Fxc. And ito yung formula, no? Dinerive natin dito. Makukuha mo yung value ng capacitance na 81.2184 microfarad. Kasi 0.00 something yan pag dinivide mo. Pag bumibili ka naman ng capacitor, naka-microfarad or naka-picofarad yan. Next power factor is cosine theta. Ang pinili ko ay ER over E. 100 volts divided by 220 volts, nakakuha ka ng power factor na 0.4545 leading. No? Kasi capacitive siya. Leading siya. Pag capacitive, leading kasi nauuna yung voltage sa current. Or I mean, leading siya dahil nauuna yung current sa voltage. Ito ang itsura. Nauuna yung current sa voltage. Ito yung 220 volts na source. Ito yung E sub C, ito yung E sub R. Phase angle, R cosine of 0.4545, makukuha mo 62.9672 degrees. Example 2. a pure resistance of 50 ohms is in series with a pure capacitance of 100 microfarad. The series combination is connected across a 100 volt 50 hertz supply. Find letter A, the impedance, B, the current, C, the power factor. So given R is 50 ohms, the capacitance is 100 microfarad, yung source voltage natin ito is 100 volt, 50 hertz yung frequency. Ang required ay impedance, current, tsaka power factor. So, taas natin ng konti, din-drawing lang natin yung illustration niya. Power factor is cosine of theta. Ang cosine ng theta sa impedance triangle is R over C, which is 50 ohms over 59.272. So, power factor is 0.8436 leading. Tapos, solution, ding impedance E over I, which is equal to R squared plus XC squared. Yung X sub C is 1 over 2 pi FC, which is 1 over 2 pi 50 times 100 times 10 to the negative 6 farad. X sub C is equal to 31.831 ohms. So, say is 50 ohms squared plus 31.831 squared. So, yung impedance is 59.272 ohms. Letter BI is E over C, 100 volts divided by 59.272 ohms. Makakakuha ka ng current na 1.6871 ampere. Ito yun. Then, example 3, a 240 volt 50 hertz series RC circuit takes an RMS current of 20 ampere. The maximum value of the current occurs at 1 over 900 seconds before the maximum value of the voltage. Calculate the power factor, average power, the parameters of the circuit. Ito yung given, no? Yung source ay 240 volt, yung frequency ay 50 hertz. Yung current na dumadaloy dito ay 20 amperes. Yung time is 1 over 900 seconds. So required yung power factor, average power, yung parameters ng circuit, no? So power factor has a formula of cosine theta. Ang theta is angular frequency times time. So 2 pi f. So theta is 2 pi ft. So 2 pi times 50 hertz times 1 over 900 second, makakakuha ka ng 0.3491 radian. So power factor is equal to cosine of 0.3491 radian. Ang power factor niya ay 0.9397 leading. So leading siya. Capacitive eh. Power is EI cosine theta rin. Ito yung isang formula rin ng power. So 200 times 20 ampere times 0.9397 yung power factor. Makakakuha ka ng power na 3.7588 kilowatt. No? Taas ko lang. Yan. Lipat tayo ng page. Parameters of the circuit. Ano-ano ba yung mga parameters? Impedance. E over I, 200 volts divided by 20 amperes, 10 ohms. Yung impedance triangle, ito yung formula. So, X sub C is the impedance times sin theta, no? Kasi reactive power to, no? Sin theta. So, masosolve mo ngayon dito yung, sinosolve natin ngayon dito yung X sub C. Paano mo masosolve yung X sub C? 10 ohms times sine of the radian, 0.3491. Dapat naka-radian yung calculator nyo rito, ha? Tinawin ko lang. Kasi mamamali kayo pag naka-decrease yung calculator nyo. Shift function, radian ang pindutin nyo para makuha mo yung tamang sagot. So, X sub C is 3.4205 ohms. So, X sub C is 1 over 2 pi FC. Solving for the capacitance, makakakuha ka ng 900 microfarad. So, RLC naman, no? Resistance, inductance, and capacitance in series. Tingnan ko lang kung hanggang saan natin pwede paabutin. Magtitira naman tayo hanggang next meeting, no? So resistance, inductance, and capacitance in series. Condition pag RLC, no? The current is the same in all parts of the circuit. The current vector is used as reference vector. The voltage across the inductance and that of the capacitance are in opposition. The line voltage must be the vector sum of the three voltages. So kung mas malaki yung inductive reactance sa capacitive reactance, the tangent is positive and the phase angle is positive, no? Teka lang ha. Wala kasing Greek letter dito eh. Sandali lang. Walang tayo ng Greek letter. Saglit lang. Para malinaw. Pati sa notebook nyo. Saglit lang ha. Kaya yung Greek letter na theta ang hinahanap ko. Saglit lang. Punta na ako sa open board. So XL is greater than XC. The tangent is positive and lang. Yun, may Greek letter na ako. Para maayos pagdating sa notebook nyo. Kaya, yun. X sub L is greater than X sub C, the tangent is positive, and theta is positive. This shows that the current lags. No? So, makikita mo, nandito na lahat yung um, component, no? Resistance, inductance, capacitance. So, with respect to the vector diagram, yung resistance, makikita mo in phase sa axis ng current. Wala siyang phase angle kasi purely resistive siya. Yung purely inductive naman, nagli-lead yung voltage sa current, naiiwan yung current. Kasi ito ay current, no? Yan. Nauuna yung EL sa I. Tapos, nahuhuli naman yung capacitive voltage sa current. So, kung ano yung mas malaki sa kanilang dalawa, yun yung mangingibabaw kung leading or lagging. Of course, kung mas malaking yung yung inductive reactance sa capacitive reactance, magiging lagging kasi nahuhuli yung current sa voltage. Pag mas malaki yung capacitive reactance sa inductive reactance, kasi ang reference natin current Reference natin ito current, magiging leading kasi mas nauuna yung current sa voltage. Ulitin ko Kapag mas malaki yung inductive voltage kaysa sa capacitive voltage, magiging lagging siya kasi nauuli yung current sa voltage. Reference natin current Kapag nauuna yung current, kapag mas malaki yung capacitive voltage kumpara sa inductive voltage, mauuna ngayon yung current. Kaya siya ay magiging leading. So, ito yung magiging itsura niya, no? And, if the capacitive reactance is greater than the inductive reactance, the tangent is negative and the angle is negative. The current is leading, no? Ito yung binabanggit dito. Taas ko lang. So, ganito na-derive yan, no? E is equals to ER squared plus, siyempre, EL over E minus EC. EL squared minus EC squared. So, ER squared ay may formula na IR squared plus yung formula ng EL, IXL squared minus IXC squared. So, I squared R squared plus I squared XL squared minus I squared XC squared. So, I squared R squared plus I squared XL squared minus XC squared. You have I squared R squared plus XL squared minus XC squared. And then, kunin mo yung square root, syempre matitira na lang ito, no? Yung R squared plus XL squared minus XC squared, parenthesis overall. Yung I squared, mawawala na sa square root kasi yung square root ng I squared ay I. Kakancelin mo na lang yung current para makuha mo yung formula ng impedance based from the impedance triangle. Ito ngayon ang lalabas na formula ng impedance. Ito. So, yung phase angle, arctangent of EL minus EC, EL minus EC over ER, which is equal to, natingin ako dito sa sa voltage triangle dito. EL minus EC, dito itong naka-synchronize kasi ito dito. So, EL minus EC over ER or XL minus XC over R. Nasaan yung XL? Dito rin sa lugar na to. Or QL minus QC over P sa power triangle naman to. Kasi ito yung reactive power. So phase angle between E and I is theta. Tinatawag din natin phase angle between C and I, phase angle between the apparent power and the current, no? So ito yung power triangle natin. Yung true power, makikita mo yan sa circuit na nakaparallel mismo sa resistor. Yung reactive power, which is whether inductive or capacitive, sa capacitance yan at saka sa inductance. At ito nandito, ito yung total. Ang tawag dito sa S ay apparent power. So power is EI cosine theta or it's given by I squared R. Reactive power is EI sine theta or I squared XL minus XC. So example 1, a voltage of 220 volts at 60 cycle is impressed on a circuit having 50 ohms resistor, a 25 microfarad capacitor, and a 0.2 Henry inductor in series. Determine the impedance, total current, voltage across resistor, inductor, and capacitor, total power, power factor, and power factor angle. Draw the vector diagram. So ito yung mga given, 220 volts, 60 cycles per second, 50 ohms, 25 microfarad, 0.2 Henry inductance. Hinahanap yung impedance, current, ER, EL, EC, tsaka power. Yung power factor, tsaka yung phase angle, yung vector diagram. Solution, yung impedance is R squared plus XL minus XC squared. Ang XL or inductive reactance is 2 pi FL. So 2 pi times 60 times 0.2, makakakuha ka ng 75.3982 ohms. So, ang capacitive reactance is 1 over 2 times pi times the frequency times the capacitance. So, you have 1 over 2 times pi times 60 times 25 times 10 to the negative 6. Yung capacitance natin, makakakuha ka ng capacitive reactance na 106.1033 ohms. Yung impedance is square root of R squared plus parenthesis XL minus XE squared. Makukuha mo to. Makukuha mo yung impedance na 58.6754. Yung current is E over C. So therefore, 220 volts over 58.6754 ohms, 3.74794 ampere. Yung voltage drop across resistor, makukuha mo na 187.4721 volts. No? Yung inductive voltage I times XL, 3.7494 times 75.3982. Yung inductive reactance, makakuha ka ng 282.6980 volts. Yung capacitive voltage is I times XC, makakuha ka ng 3.7494 times 106.1033 ohms. So, ang capacitive voltage ay 397.8237 volts. Power is EI cosine theta. Or so also, pwede mo rin siyang tawagin na I squared R. So, the power is 3.7494 squared times, ginamit ko itong formulang to, no? 50 ohms. Nakakuha tayo ng power na 702.7501 watts. Ang power factor is cosine theta, R over C. So, 50 ohms divided by 58.6754 ohms. Yung say impedance yun, ha? Power factor is 0.8521 leading. O bakit leading na yun? Mas malaki yung capacitive voltage sa inductive voltage. Kaya leading siya. So yung theta niya is R cosine of 0.8521. Ang phase angle niya ay 31.5592 degrees. Ito ngayon yung vector diagram niya. Mapapansin mo, leading siya, no? Kasi nauuna yung current sa voltage. Nauuna yung current sa overall voltage niya. Na overall, hindi overall voltage, nauuna yung current sa reactance. or reactance voltage. Ito yung assignment, no? Hindi ko na muna isasama itong data. Bibigay na lang ako ng dagdag na assignment. Sinold ko kasi yun. Dadagdag ko na lang yung dagdag na assignment. Dagdag lang ha. Wala pa pala tayo sa resonance. Resonance problem 'to, eh. Okay, stop ko na yung recording ha. Na-send ko na eh. Wait lang.